Hi everyone, and welcome back to another session of Shifting Gears with SDV. I'm your host, Ludmila Muña, and I'm excited to welcome our guest speaker today, Daniel Gribner, who will be presenting Applying and Scaling Trustable Software Framework. Thank you so much, Daniel, for being here today. If you have any questions during the session, please feel free to drop them in the Ask a Question tab or directly in the chat. And with that, over to you, Daniel. Thank you.
Thank you, and thanks everybody who dialed in today. I want to give you a intro and an overview to a little project that I built earlier this year, and essentially the project was about exploring and getting a bit hands-on with a Eclipse project that has been live for about a year now, I would guess, the Trustable Software Framework project. So what is this about? At the end of the day, the TSF is a software quality method. And if we take a little step back and just consider how an open source project typically operates versus what is often implied by the application of software quality frameworks and methods. This here is a little brief overview / discussion starter that at least, that's what kind of my mind space is regarding these topics. So open source projects, regardless of whether they are backed by commercial entities or not, are usually understaffed. There's always more issues and more things that could be done compared to the people who actually are able to work on these code bases, on these projects. And therefore, open source projects tend to be very, very hands-on and result-oriented. And there is little patience for people who, make intelligent recommendations that certain things should be done. Like, you can do them yourself if you care, or please let us go ahead with whatever our plan was. That's one of the feelings I think that prevails. And any added work, any extra artifacts, etc., that people might request or demand, well, if there is no direct visible value add, it gets very hard to argue for the creation and the maintenance of such artifacts, right? Because why should I create, a specific form of a requirement specification that essentially only one party is interested in? Nobody else needs this stuff, and it really does not help me get ahead with what I need to do actually. So that's the kind of mind space and the kind of approach that, due to the staffing restrictions, often are relevant and existential in open source projects. And if you contrast that to the, let's say, commercially driven or commercially hosted application of formal software quality methods, money is always tight, etc., but you do often get the opposite picture, where the approaches, the methods, the tools that are used, and so on, are very often extremely labor intensive and process heavy. There's different drivers here, right? So commercial companies building and selling products do have to manage their liability, and that means they do have to care for anything related to compliance for their product, and that gives a different kind of priority to related tasks. But everybody probably has been at the receiving end of some of these approaches, where you get 6,000 line Excel checklists that you have to go through for a release or something. This stuff is, again, labor intensive, process heavy, and because often these processes have been around for a while, they tend to, at least the ones that have been around for a while, tend to be very hard to automate, because again, automate filling in an Excel checklist, that's not going to go down well. And essentially, this gap or this contrast between software quality methods, how they used to work, and open source restrictions is why I was getting interested in perking up when I learned about the Eclipse Trustable Software Framework project. So Eclipse TSF is, at the end of the day, a combination of a software quality measurement and assessment methodology, and a actually quite small and simple little tool that helps with applying the method. We will get to the core idea in a second. But on a high level, this is a method that's from the get-go designed to be applicable in resource-constrained environments, at least compared to the traditional approaches. So like everything that TSF needs you to do is essentially revolving around, well, text files, snippets that live in your repo, together with any other artifacts, code tests, etc., that are in your repo, and the little tooling that helps you manipulate the TSF-related artifacts. Again, this is a command line tool, so it's from the get-go designed to be integratable into CI, into scripts, and so on. So even though TSF has been put together with the intention of putting something out there that can be a lot more useful in an open source context, there is still a few things that essentially I took on after I found this and observed it for a while. So in general, let's say, for somebody who has not been exposed to software quality methods and the mindset behind that, it can be challenging just to get the idea and to understand the goal and kind of form an opinion and some routines about how to apply the stuff. And then you get into practicalities where, okay, I get this. This is something where there's a little tool here. Okay, fine. I do have CI in my project. Okay, also fine. But actually, what should it look like if I put these together, right? If I apply the method and then try to automate stuff, like can I look into some examples here? Can I get some inspiration? What other little tools, concepts might be relevant in the context of some project that's looking to apply TSF? And I guess, once you get going, once you get started, there's a myriad little things like that that you essentially run into and that you would like to get some inspiration or starting points for. And so the starting point, the getting started thing, that is something that I put together earlier this year again. I also spoke about this at the OCX in Brussels this year. So if you want a different version of this presentation, you will find that on YouTube. And I will now briefly talk about what TSF is, what the underlying idea is, and then take you through the application of that idea into something that I call TSF template. Probably not a great name, but it's a little Hello World style application of the TSF method in an open source repository. All right, so briefly about TSF. What is the core idea or the approach taken and defined by the method? So at the heart of it, this is a method for defining in a structured way and in a machine-readable way for structuring quality goals of a code base, let's say. So the idea is that starting with a core set of headlines for the different dimensions of quality that you might pursue in a project, you are essentially able to and expected to add and break down these top-level, high-level goal statements into more specific goals that directly apply to your project. So, a high-level guide or a high-level topic might be. You can see on the slide here. There are two examples for the TT dash headlines. So a high-level guidance might say you need to provide documentation, you need to specify what your thing, what your code is expected to do, what it shouldn't do, and how this is verified. And then this is broken down already in the TSF method. So this graph snippet here, that's an outtake from the core documentation of the TSF method. And you can, essentially look into the child element, the child node, the TA behaviors node down there, where it's described that you are expected to have a specification for the expected behaviors of your thing, and essentially a description of how you verify and validate your specification there. And so the idea, if you apply this stuff, is you take that starting graph, that root essentially of a tree, and for every of these nodes there, you begin to do a breakdown. So like in my project, how do I actually define required behaviors? And in my project, how do I verify those? How do I validate? And so on. So the idea is to break these top-level quality goals down to something that you, in your specific code base, can make a true or false statement about. So you might say, I've got a specification, a requirement specification, where I do define the expected behaviors, and this is provable because you can point to the specification. And if you cannot point to the specification, well, then obviously you missed that goal. And in a nutshell, that is the methodology part of TSF. You go through the graph for everything that you do that answers or details out one of these headlines. You create new graph nodes that you link into the graph at the end of the day, or at the end of this work. You get a bigger graph, with the TSF top-level stuff and all of your details, all of your detailing that you have applied to your context. And then what you can do, and again, that's where the little tool comes in that comes with the method. You can then go through your graph. For instance, when you do a release of your code, of your thing, you can, in an automated or manual way, or like a mixture of both, you can go through the graph, look at every node that you have added, and essentially check whether you have evidence to prove whether you have achieved that goal. So going back to the example earlier, you might be able to point to your requirement specification, and therefore you have something that supports your statement that you are doing the TA behaviors thing properly. And if you do that, if you have proof, then the tool can essentially create a score, and every node can get a score, and you can essentially compute scores for each of the graph nodes, and that gets distributed up into the graph, and every node at the end of the day will have a little score back to the root, the trustable software root node, which again gets an overall score. And so that is the second part of how to use TSF. When you have detailed out the graph, you have all the evidence that you need, you can then do a regular, maybe think of dashboard, think of release workflow, think of maybe even PR merge, depending on what you're doing there exactly. But you have an automated way of assessing and tracking your, the quality level that you're reaching compared to your stated objectives. So that is TSF in a nutshell. I will say this again probably, but the TSF folks are extremely open and friendly and nice. So if this sounds in any way interesting, head over there, look at their project, get in touch, because any questions you have, they will be happy to answer, and they do have extensive documentation. So again, have a look over there. It's generally worthwhile. Maybe again, taking a quick step back, because I haven't mentioned this so far, but for obviously software quality measurement methods, or in general software quality methods, this isn't something new, right? And especially in our industry, in the automotive industry, and other safety related industries, everyone has their own approach to measuring, defining, validating software quality. Now the question is, compared to these methods that we all have known for decades, what's that TSF thing? Like, how does that relate, or how does that compare? For me, again, no details here, but what I did put in is an excerpt of a report that was published by CodeThink, the company that has come up with the TSF method. And the upshot is that they are working with a certification authority, and the assessment for TSF as a software quality method essentially says that if you apply this method properly, then you will be able to meet or exceed the expectations established for software in that IEC 61508 standard, SIL level 3. There's more details. You can read the rest yourself. The slides will be made available. And again, this is just me nicking the information from CodeThink in this case. But what I'm saying is that the method as such has been vetted, has been reviewed, and has been found to be, supporting the necessary rigor and results that are needed to get you to the software quality, safety quality levels that we usually need or have to provide evidence for. All right. Now let's get into the TSF template project again. That's something that I built initially to help myself understand the idea and the method. This is available on GitHub. There's going to be a link at the end. I hope to be able to hand over the core of this, for instance, to the TSF project to be made available there, part of the extended documentation maybe. And so consider the current location as temporary. But essentially what I've built is a workflow and the related CI/CD definitions and so on, the pipelines that shows or essentially gives you a starting point for how TSF might be used in a project from start to end. So you can think of this as it's like just an inch deep, but I'm trying to be reasonably complete from start to finish, or like from beginning of the application to like the automation of report generation and scoring and so on. So there's not a lot of content, but I do try to cover the entire development process. And what I essentially did there to group this is I'm thinking about this in 3 stages, where the first initial stage is a setup stage where you put the necessary pieces in place to then be able in your continued development testing cycle to apply and build out the quality artifacts. But vision stage 1 is essentially setup and initial tailoring. Stage 2 is the continued application and little work items that you do to extend your graph and to essentially do anything necessary to be able to create your TSF scoring and to improve your scoring over time. And stage 3 is an automation stage where, based on your quality artifacts and based on the work that you're doing in your iteration cycle, you can now get the automated scores, the automated reports, and any other artifacts that support your quality claims. So stage 1 setup, stage 2 is like the day-to-day work that you do based on your setup. Stage 3 is the, for instance, release automation that uses your work, publishes reports, generates artifacts, and essentially builds off all of that work that you did to get you inputs for a safety case, for example. And for TSF template, in general for TSF, but also in TSF template, let's look at stage 1, where I think that there is a huge potential benefit of using an open source, an openly developed quality method. So I did mention the word tailoring earlier, and I did describe the TSF method even before that, where what I said is you take the core graph of quality goals and then you break that down and detail it out to fit your project. Now, what you essentially do in that detailing step is you adapt to your context, right? You essentially come up with details and aspects of the main quality thing, of the main quality goal that apply to the context of your project. And now the beauty of doing something like this in an open source way is we all share context. So for example, some of us at least share a technical context. So every Rust project, for example, has very easy access to a large Rust tooling ecosystem that gives you a lot of software quality related benefits that you can directly use and directly, prove that you are achieving certain goals because you are using whatever cargo deny to make sure that your license and related regulations are, met and controlled. But there's many examples like that. So essentially what I'm saying is, for instance, every Rust project shares the same technical context for reaching certain quality goals in the TSF graph. Or a different non-technical example might be process context. So like I do hope that many of you at some point have looked at, maybe even read the Eclipse development handbook and the project process guidelines that exist. And every Eclipse project is expected to follow the process and the guidelines that are defined there. And that means that every Eclipse project shares a bunch of process context that also help to fulfill and improve your score in certain of these TSF headline areas. So what I'm saying is, although every project shares certain context, every project does not have to reinvent that wheel. So we can share these tailorings. We can share libraries for, you are a Rust project. Okay, here's 18 quality goals, TSF quality goals that you can reach easily because you are using Rust. You can use those goals directly in your graph to get you started with your TSF application. Or you are an Eclipse project, right? Here's 20 quality goals, breakdown goals that fit into the TSF graph and that you as an Eclipse project should be already essentially reaching. So again, we don't have to reinvent the tailoring for these shared contexts. We can reuse libraries, statement libraries or tenant libraries. And so what I did is, for TSF template, what I did is I created an example or a starting point for a Eclipse Foundation process tenant library. And that starting point is part of the TSF template repo. So there you will find, I don't know how many off the top of my head, but let's say 18 or something quality goals directly derived from the Eclipse process definitions, that link into the TSF graph with documentation and details about each of these items that you then can use in your Eclipse project to directly begin to cover a certain, not huge, but also a still substantial part of your TSF graph. And again, the TSF template thing is supposed to be a Hello World project where I illustrate the idea. However, I do have hopes that going forward, we can create something like a TSF statement library, maybe contribution project within TSF itself, where we can grow the library of supported context. You can think of something, the Rust example, you can think of a library, a tenant library for many programming languages. Some might have more assets going for them than others, of course, but every language probably has something. Every ecosystem has something. And so I do hope that over time we can take a huge part of the getting started burden for actually using the method, can get it offloaded, because if you are a certain tech stack, if you are in a certain process context, you can just pull in those libraries and get you going. So that is essentially the TSF template idea for supporting the stage 1, the setup stage. Stage 2 is the doing the work stage. That's the thing where you do whatever you do when you're a developer in an open source project, plus the things that you need to do to support your TSF method, the TSF scoring and so on. And I already was talking about the two core pieces that need to be done here. So, I mean, a developer, is essentially reading, detailing out, discussing issues in whatever platform, issue tracker, etc. they are using, GitHub, etc. And then they are writing code, they are writing tests, they are creating pull requests, merge requests, they are discussing and reviewing those, and at some points these get merged, you do your releases and so on. That's the normal flow, the normal course of work. Using TSF will add or does add at least 2 steps or 2 activities to this normal work, let's say, where the first activity is, as you go along, as you add features, as you add capabilities to your code base and to your project, you probably should also, frequently, whenever it makes sense, review and extend your TSF graph. Like if you have new quality statements or new things that support certain quality goals, you should add new nodes in your TSF graph to capture and record those things that you have done. That might be tests, that might be new requirements or new ways of doing a validation or whatever. But many of the work items that you perform day to day might play into improving some of your quality measurement scores, and you should essentially be aware of that / build your graph as you go along. So that's stage 1. Add new details to the graph wherever applicable and meaningful. And stage 2 is something that I'm going to show you in a bit more detail later, because not only do you want to extend the graph, but you also want to be able to automatically, wherever possible, automatically score whether you're reaching those goals. So add a new item, but also think about, okay, how could I, going forward, how would I prove that I'm actually, reaching that goal, that I've got something going for this quality goal that I've defined here. So thinking about what kind of evidence would satisfy this goal, and then ideally automatically recording the link between whatever the evidence is and that statement, so that going forward, the verification of evidence and the scoring can be automated as much as possible. So in a nutshell, for the stage 2, the iteration, the day-to-day work, there's 2 added steps where you build the graph as you go along. And when you build out your graph, you continually think about, okay, how can I prove that I'm reaching these goals, and how can I capture, or now then let me capture the link between the evidence and the goals that it's supporting, so that going forward, scoring can become or can be more and more automated, and I can essentially automatically track coverage of my goals and the trends over time and so on. So that's the nutshell for stage 2. And once you've done all of that, we get into the stage 3, where automation ideally can use and pull together all of the work that you've done to create all these nice quality artifacts, again, that you might then use for something like a safety case or an assessment or whatever. So we do have a bunch of things in our repo. We have code, we have tests, we have specifications, we have documentation, we have configurations, we have anything and everything of that a project carries. We have built out our TSF graph. We have recorded links between evidence items and the TSF goals. Now what we can do, because all of this is essentially some form of machine readable content, we can now create automatic build pipeline, release pipeline level functionality to pull all of this together, right? We can, when we do our release and we run tests and we do, coverage analysis and whatever else we might be doing, also in that flow, we can analyze our TSF graph. We can look for every item for all of the evidence that might be available, and based on the graph and the available evidence, we can now automatically score our graph and generate a associated report. And all of this we can again automatically export, publish to websites, to project documentation, whatever we might be using and needing. And so this flow, this let's say release flow, for example, that is the third piece that I have implemented in TSF template. Again, I'm not saying this is the way or the only way, but it's one way, and hopefully it's a way that can be useful for gaining an idea of how this might be used and might be beneficial. So to kind of get a little bit more hands-on / a little bit better impression of what that really actually looks like, let's look at the 3 stages again. But we'll look at a little bit more, not quite code, this is not an IDE, but let's say almost code, like this is screenshots and so on. And again, you will be able to find all of this on GitHub. So essentially, as I said a couple of times now, stage 1 is setup and tailoring. And you do get from the TSF method, you get your core graph, the snippet I was talking about at the very beginning. Don't hold me to that, but something like a dozen or maybe dozen to 20 items in there. I have picked out, for this example, I have picked out a path into this graph starting from the very top, where we can see the Trustable Software top level item. This one is then breaking down into the headline TT expectations. Again, I spoke about this earlier. You can read the text on the slide, but this is about all forms of documentation and specification for a code base. And then there's a sub aspect here where we want information about the release process and the recreation, like the documentation of how releases are built and managed. For instance, like just very simply, how can I, a little developer, run a build for this project, and maybe how does the release process work? So those 3 on the top, these come from the TSF method itself. That's like one path into that tree. So as I spoke about earlier, what I'm adding to this is I'm adding an Eclipse process library, because the Eclipse process also has things to say about the documentation of how you do a release and how you do a build and how you get essentially on board with all of that stuff. So what you can see in the blue outline is a Eclipse project README breakdown item that is derived from the Eclipse documentation, project documentation, and is a further little detail step on the TA releases item. So it's a breakdown of that that's coming from the Eclipse process definition. And again, this is one path through that tree. Imagine something like this for at least 10 or 12 items. Again, look at the code base. I don't remember right now how many I've got, but something like 12 to 18, I think. And now the blue thing is the tailoring, based on the Eclipse process, and there might be other tailoring sources. So, there might be more breakdown happening here, but again, for TSF template, I was trying to keep it simple. So what I did then is the project level tailoring at the bottom, the orange outline. This is where for TSF template itself, I'm adding a falsifiable statement about this project, where I'm saying, okay, TSF template itself does have a project README, and the README is essentially giving an overview and intro to the goal scope and the getting started documentation, like including how to build and so on. So this is not the complete breakdown of that graph. There could be an arbitrary number of breakdown items, but this is one item that I'm linking into this. So just to recap, we have the core statements that come from the TSF core project. Then we have an example of a context-based tailoring with, in this case, an Eclipse process-derived statement library that we can link into the TSF graph. And then we come in with our project level tailoring or detailing, where we make a specific statement about this project that is directly falsifiable, right? There's a README, there's no README. Okay, we could have details later whether the README contents actually kind of are as expected, but you get the idea. And what this looks like in the code, quote unquote, the TSF items that we have been seeing so far in your repo, these are markdown snippets. And you can see here now the same structure, like the gray core items, the blue process-based statement library, and the orange project level tailoring or project level detailing. That's the same structure as we just saw on the previous slide, but this is essentially just the markdown as it's located in the repo. It's the same text as in the graph items in the graph visualization earlier, but here you can directly essentially manipulate, read, look at the markdown that is then also used by the tool for scoring and for building your graph. There's one little thing I want to highlight here. I did highlight here actually with the red box. What I'm doing in TSF template, as I announced earlier, I'm also suggesting or offering a way for doing the automated report generation, the evidence scoring. And for that reason, to be able to automate this, what I've put here in the project level statement, it's a little placeholder, the little thing that's highlighted with the red box. There is a comment item there, says evidence ref. This is essentially the front matter here, the header of this markdown. This is where the TSF tool keeps metadata. There's various metadata, could be author. There's a bunch of things. Again, look at the TSF documentation. One of the evidence, one of the front meta items is links to evidence for this specific statement. So there's a syntax defined over there, how you can, in that header, reference whatever kinds of evidence might support this statement. And so what I'm doing here for now, I made my statement down there, and I'm providing a little placeholder up here where later evidence can go. Again, we will see this in a minute. All right. So that was stage one. That was the setup part, right? Build your graph and detail out your graph and think about what kind of evidence might support your graph. And now, essentially, we come to the evidence recording. How could that be done? Right? We have thought about how you might provide evidence for my statement. My statement was my project has a README. Okay, how might we provide evidence of having a README? Thinking about, for example, about a release workflow. Well, what we could do, because it's easy, is we could, when we do a release workflow, we can just collect a bunch of artifacts from our project, either static, like a README, or it could also be dynamic artifacts, like a test report. But we do have a bunch of artifacts available, and we can just essentially collect them when we do a release, for example. So, like, by collect, what I mean is it's possible and easy to upload files, for example, to your GitHub, to the release that you're doing on GitHub. So you can have, besides the actual binary or whatever you have been building, you can have a bunch of files, bunch of artifacts along with that support the release. And that's one possible way of doing this kind of thing. And that's, like, again, it's an easy, straightforward way. So that's what I've been doing in TSF template. And you can see a two-step thing here, where the first step is the obvious easy one. As I just said, we upload our README file to the release that we're currently doing. This is a GitHub action from somebody, available and for use by everybody. And what this does is it simply picks our README file and uploads that alongside the other release artifacts when we do a release workflow on GitHub. That's hopefully not news to people using these platforms. That's something that happens, that people do a lot. The second step is a little bit more, let's say, interesting, because this is something that I created for TSF, for TSF template for the TSF application example. This is a GitHub action that I wrote myself for this purpose and that I'm using here. The GitHub action is called TSF fur. That's very clever for TSF transfer. And essentially, I need to record something here. So I need to record the link between my evidence item, in this case the README, and the TSF graph node that this evidence item is supporting. So that's the information that I need to record somewhere so that I can then later combine these things and score how well I've been doing regarding my quality. And so what I'm doing here is exactly that. The TSF action is taking these two pieces of info. It's taking a link, a pointer to the evidence, and in this case, in the middle, you can see reference properties, and there's a URL there, and the URL is essentially directly the release upload download thing from the previous step. That is the download URL later for getting the README file of that release. And that is the first piece of info that I'm recording, and the second piece of what does this evidence belong to. And so at the bottom, again, in the red box, you can see the ID of the graph item that this little evidence reference up there is supporting. So that is the second part of the, let's say, day-to-day workflow, where whenever you have a new piece of evidence, you should create a recording, a link of that evidence to the supported graph node. The way I'm doing it here is by putting that into my release workflow. This is also on GitHub, obviously. The action is public. We can look at what it's doing in detail, but very briefly, this is not magic. This is simply creating a little JSON snippet in the context of this GitHub workflow, of this release workflow. And the JSON snippet is containing all of the info I'm putting in here. So this is essentially just saying, okay, these reference properties and all the properties down there, just output these to JSON that I can look at later. That's what these actions are doing in this stage. So what we have at this point, we have a TSF graph next to all the other regular artifacts, code files and so on in our repo. And we have a GitHub action flow where we do record the relationship between these evidence reference links and the graph nodes that they support. And all of this now allows us to do the automation in stage 3, where this looks very unspectacular from a TSFer point of view. That was the idea, because what I've done here, this is essentially almost the end of the release workflow. And this is calling it another little GitHub action, again, publicly available. You can look at that, called TSF link. And TSF link is doing what I just was talking about. So what TSF link does is, after you've done all of your release activities, again, you build your software, you test your software, you record test reports, you do whatever, and you have done a bunch of these TSF JSON snippets where you document the relationship between evidence items and your graph. The TSF link action will now collect all of these JSON snippets, and then it will, if you remember, it will go through the TSF graph nodes where we had the little placeholder in. It will put all of the evidence links into the related placeholders, and that will give you the complete TSF graph with all the evidence links included, because again, TSF link just added them. And then you can, or TSF link will use the TSF tooling to do the scoring of your graph. So it goes through all the nodes. It looks everywhere where there's linked evidence. It might even be able to, validate, essentially check some of the evidence. There's plugins for that, could be done. And then based on the state of the evidence and the graph nodes, it will create quality scores across your entire tree. And it is also a built-in feature of that tool. It's able to publish a comprehensive report of the TSF quality that you have reached in this release. Essentially, it will give you a dashboard. It will give you a detailed, clickable report where you can essentially drill down in all of the details and so on and so forth. So long story short, the upshot of all of this is, after you've been doing the setup and the day-to-day work with the evidence linking, you now can run releases where you will get, quote unquote, for free, along with all of the other artifacts, you will get TSF quality reports and scoring. Again, you can look at what this is essentially giving you, at least in the TSF template example. You can look at that online. I do have to admit, there's currently, I did a little version bump of some tools a couple of weeks ago, and the requirements tracing is not what it should be. But there's something there, and I'll fix it soon. Anyways, you can look at the report that is generated and all of the details that are provided there on the TSF template website. So at the end of my release process, I'm uploading all of this stuff to GitHub Pages, so you get a very, again, nice, polished project overview with all of the documentation linked and links to the requirements tracing report and the complete trustable compliance report. All the details, all the drill down items, and so forth. So that's available at this link, or directly from the repo if you follow the GitHub Pages link on there. And to wrap this up, because I was just mentioning requirements, there's a neat little detail that I also put in, again, because I wanted to figure out how and what it might look like. So, requirements are obviously very important in our industry, right? We love requirements. And there do exist open source tools for managing and tracing requirements. One of these tools is called OpenFastTrace. That's, again, a combination of, it's been around a long time, and it's simple and very specialized to requirements tracing. So it's, it does its job, and it's not overcomplicated, which is why, for example, we are using OpenFastTrace in the uProtocol project to do our requirements tracing. And I also put in OpenFastTrace-based requirements tracing into TSF template. And what I'm put together on the slide here is essentially the complete path from how the specification of requirements items is done in TSF template to the way I'm essentially referencing the requirements or specific requirements in my TSF graph, and how I'm linking a requirements ID to my quality goal and the final report. So on the top left side, you can see a snippet from the TSF template requirement spec. It's maybe a page or 2 pages long. It's not, maybe it's shorter, but essentially, again, it's supposed to just give the general idea of how requirements specification can be done using OpenFastTrace. And you can see, very simple requirement around the project README again, with a requirements ID on the top left screenshot. And then we do have a implementation. So this is essentially a text in my README that tries to cover the requirement up there. It tries to provide a certain level, a certain kind of information to satisfy that requirement. So top left is where I'm essentially implementing the requirement and providing the requirements markers that OpenFastTrace is using for its tracing. And then what I'm doing is in my release workflow, and you remember the TSF action item where we do link evidence to specific graph nodes. So here I'm using a requirements ID as my evidence So I'm linking a specific requirements ID into my TSF graph. The TSF graph about the README you saw 2 slides ago. That was the thing about the README. And now here I'm providing evidence by pointing to this requirements ID that you can see on the top left side and that we're implementing on the bottom left side. And the end result of all of that is that when I run the reporting and I publish the report, I now can click through in my TSF report for this specific item, and it will give me the evidence here, the requirements ID evidence. It will give me all the details that it could derive from the requirements tracing. So it gives me the original statement. It gives me where the statement has been defined, what the needs of that statements are. Right, this one needs an implementation, could also have been a test, etc. It tells me whether this need is covered, and it also gives me all the relevant places where coverage, testing, etc. might have happened in my code base. So this is I think, very neat combination of the high-level, top-level quality reporting and analysis with the more detailed, and code-specific, code-oriented requirements tracing, where you get essentially from your quality goal down to your requirements definition and implementation and testing and so on. So again, this is almost for free because the tools are open source, they are there. The combination of the tools is not rocket science. And when you apply the method, the TSF method, as I've been talking about earlier, this kind of detailed report and detailed link from beginning to end, this is essentially, I wouldn't say completely free, but essentially there's a lot of potential here, I think, for getting to a much higher level of software quality awareness and reporting that's just available without having to, going back to the 6,000 lines of Excel checklist that I talked about earlier. All right. So this was the overview of TSF template, trying to be a Hello World style inspiration starting point for applying the Trustable Software Framework method. As I mentioned, I have to pick this up again after the summer break, I guess. I would hope that the TSF project itself and or the Eclipse Dash project want to pick up some of the tools that I've created for this, for extended documentation and the GitHub actions for putting this into your own pipelines, essentially. And if you want to know more about TSF, the project, and where this came from, what the underlying rationale is, there's a link here for you. Again, slides will be shared. And with that, I'm through with TSF template. This is the link to the repo. Have a look. Would be happy to take any questions or discussions here or there, or in the future in general. I think TSF is the first method that is really interesting for usage in an open source development model, a development context. And I do think it would be worthwhile, especially in our community, to begin to apply it and to build out the tailoring library and just, kind of begin to make this something that's not esoteric that much as maybe something that's, the good practice, best practice for projects who really take these quality things seriously. One can dream, let's see. Thank you for listening.
Thank you so much, Daniel, for that excellent presentation. I can see we have a few questions. In the chat, there is one from Olaf. He's asking, does TSV also ensure compliance with ISO 26262 6 requirements for SW unit design? I don't know if you want to read it yourself also.
Let's see. I probably can't make a complete answer to that, but the way I understand things, there's two parts here. The first part is the fundamental structural question, where can this method in general be used to successfully reach goals as as expected by ISO 26262. My understanding is, going back to the statement that are shared by Exeter, yes, the method can support that kind of goal. That's the general statement. Now, the interesting part is obviously what exactly does that mean for how you have to apply the method. So I would expect that there is a tailoring layer, tailoring library needed, or at least would be helpful to more directly map 26262 requirement goals, areas, design goals, and so on into the TSF graph. So, either replace the entire graph with something that's directly ISO-speak, or maybe map the ISO-speak into the top-level TSF goals. Whatever works better, I can't say right now. But something to get the language and, the wordings, etc., aligned would be probably useful. Well, and once that is there, how you apply it, the level of breakdown you achieve, the level of detail you add for your code base, that's up to you. But I would guess that you need to go as deep as you need to go, right? So your assessor will tell you what level of detail and traceability and evidence he's expecting, or she. And then this is what you put into your graph and provide evidence for. I would expect that this is the boring mechanical part. A lot of work, but hopefully not fundamental existential questions over there. Having said that, I haven't done that so far. I've not seen or been part of an ISO assessment done with TSF. So there might be people out there, for instance, looking at the ESCO Loman JSON library done by Define, I think. There might be people out there who have more detailed answers to this than I have.
Thank you
Any
so
other
much.
questions?
There is one, but look, is this question from Christian about the thing?
Well, I can only recommend everybody join us at the regular Eclipse SDV community events. I don't remember which one I got it from, but they tend to be available there. So
All right. Thank you so much, Daniel. If someone in the audience has questions, this is your moment. Please drop them in the chat or in the Ask a Question tab. We have a few minutes. In the meantime, I would like to share with you our survey. We really appreciate your feedback so we can improve our next events. Let's see. Someone asking questions? Not really. You can click in the link in the bottom, the green button there. If not, as a final reminder, also make sure to follow Eclipse SDV community for upcoming webinars, technical talks, hackathons, and other community updates. Oh, we have? Okay. No more questions, it seems. So I would like to thank you again, Daniel, for this amazing presentation today, and thank you everyone to be here with us. We hope to see you again in next webinars. Thank you. Have a great afternoon or day.
Thank you all.